Hello everyone, in today's LeetCode challenge, today we are going to discuss a problem of the day on 28th July 2025 on LeetCode, and problem of the day is 2044, count number of maximum bitwise or subsets. In this question we have given an integer array nums and we have to find the maximum possible bitwise or of a subset nums, and we have to return the number of different such non-empty subsets with the maximum bitwise or. An array A is a subset of an array B if A can be obtained from B by deleting some or possibly zero elements of B. Two subsets are considered different if the indices of the elements chosen are different, and the bitwise OR of an array is actually the bitwise OR of all the elements of that array. Now, first look at what is the subset of a set. Let us look at this example number 1. If nums array is equals to 3, 1, the all possible subsets of this 3, 1 will be 2 to the power n, where n is the length of this array, and that will be 2 to the power 2, that means 4 subsets. The 4 subsets possible from this array nums will be first the empty array, then an array containing 3, then an array containing only 1, and then an array containing both the 3 and 1. Now this 3 1 is actually equals to this 1 3. These are not different subsets because in subsets ordering does not matter. Now what we have to do now, we have to find out the maximum possible bitwise OR of any of these subsets possible from this nums, and we have to return the count of such subsets that have the maximum possible bitwise OR value in this nums array. So let us first visualize this in here. We can first find out all the possible subsets from our array, and that will be an empty array first. This is an empty array, then an array containing only 3, then an array containing only 1, and then an array containing 3, 1. Now which array can give the maximum XOR value amongst all these 4s? Let us find out. This is an empty array, so this will give maximum bitwise OR value as 0. This can give only 3 because it has only one element. This can give only 1 because it has a single element, and this array can give the maximum bitwise OR value as 3 or 1, and that will be basically 0 0 1, and the 3 is 0 1 1, and if we do the bitwise OR of this will be 1 1, this is 1, and this is 0, that means 3. So this will give the maximum XOR value as 3. Now in this problem what we have to do, we have to first find out that what will be the maximum possible OR value from our array, and that maximum possible OR value is basically given by doing all the bitwise OR of all elements of this nums array. And why was that? Because OR is an operation which only adds bits in our answer. It does not delete any of the bit from our answer because of the property that if in case there is only one or only one set bit present at any particular position, that will be counted in our answer. So that will always increase our answer or remain same, but this will never basically decreases our answer. So first we have to do the OR of all the elements of our provided nums. So we can do the OR of our array, and that will give as 3 our maximum XOR or maximum OR value of this nums. And now we have to find out that how many subsets have a maximum OR value equals to this, and we can find out that this is one of the array and this is one of the array. So there will be two possible answers for this, and we have to return 2 in that case. Now what we have to do, let us first code this and then visualize our code. First, the thing we have learned that we have to find out that the maximum XOR value is basically the XOR possible of all the elements of nums. So we can name that maximum OR val, that is initialized from 0, and we have to now find out that what will be the maximum OR value. So this will give us our maximum OR value that is possible in our array. Now what we have to do now, the total subsets are given as 2 to the power n. That means 1 left shifted by n, and this is basically 2 to the power n. This will give us the total number of subsets possible for any array. Now what else we know it? Our answer, that is initialized by 0. Now what we have to do, we have to just find out that how many subsets are possible that have the maximum XOR value equals to our this maximum OR value. My mistake, the maximum OR value. Now let us run a loop from I equals to 0 till all the possible subsets. Maintain a current OR value. Basically for I equals to 0, the pointer will starts from this position. And now what we have to do, we have to just find out that the sub array, that is subset, that is this 3 or this 3 or 1. We have to find out the maximum OR value of our subset. Run a inner loop for j equals to 0 till n, that means till its length. Now what we have to do, we have to find that if this I is left shifted right shifted by this j times is equals to 1 or not. And if that will be the case, we have to OR the value of our nums of j. And finally what we have to do, we have to check if the current OR value is equals to the maximum OR value. If it is, we have to increment our answer. And finally we have to return our answer, like that. Now what is this? Let us first run this and check if it is running fine or not, and then let us visualize this. We made a mistake, and that will be the parenthesis. Variable mistake here, maxi or value. Now it is running fine. Let us copy this and paste it here. This is for example number 1, 3, 1. Now let us visualize our code for example number 1. What we are doing? We are finding the size of our array, and for example number 1 our n will be 2. Our maximum x or value, and that will be initialized with 0 m. Let us denote this using m, and that is initially 0. What we are doing, we are finding the maximum possible or value amongst all the elements of our nums. So for every element of nums, that means this 3, this maximum or is bitwise with that element, that means 0 or 3, and 0 or 3 will be 0 1 1 is odd by 0 0 0, and that will be 3, because of the fact that if any of the bit is set on any position, the overall result will be a set value. That means 0 or 1 is 1. So this will change our maximum or value 3, and now this 1 comes in, and again our maximum or is bitwise or with this 1, so this will be 3 or 1, and only changing is this, and this time this 1 or 1 will be 1, 1 or 0 is 1, that will result only 3. So maximum or is now 3. Now our total subsets, T contains the number of total subsets, and that will be 2 to the power n. We can find the total subsets using the left shift operation. This will give as 1 left shifted by 2 positions, that means 4. This will give 4. So the total possible subsets of this nums or this example number 1 will be 4. Our answer, that is initialized with 0. Now what we are doing, we are starting a loop for I equals to 0 till I is less than our total subsets. So I will start from I equals to 0 until I is less than this n, this total, that means this 4, and here I 0 is less than this 4 comes inside. Our current is initialized with 0, and now our j is initialized with 0, and j will loop until j is less than n. So j points first here, j, and now what we are doing, we are right shifting our I j times. That means our I is currently 0, So we are basically, this right shift operation basically divides. So this 0 is divided by 2 to the power j, and j is basically 0. So this 0 is basically divided by this 1, and that will gives as 0, and this will be ANDed with 1, that means bitwise and this 0 and 1 will give as 0 because this is a bitwise, and this will results in 0. Now we check that whether this is equals to 1 or not, and here we can find that this is not equals to 1. So we are not going inside our if and just increase our j from 0 to 1. So j is 1, like this, and now this 0 is basically divided by 2 to the power 1, and this is results in 0 only. And again we are checking that this 0 is bitwise with this 1, and this will results in 0. So this 0 is not equals to 1 again, and this time when j is incremented from 1 to 2, this inner loop will gets over. So I is incremented from 0 to 1. Let us change the color. I is now 1, like this, and again current is 0. J will again starts from 0 and checked if this 1 is divided by 2 to the power 0, and this time this is 1 divided by 1, and this will results as 1. So what we are doing, we are now bitwise and or our current with nums of j, that means j is 0 and nums of j will be 3. So current is bitwise or with 3, and current is basically 0 this time. So 0 0 is bitwise odd with 0 1 1, and this will results in 0 1 1. That means current is updated from 0 to 3, like this. And again when j is incremented, this is 1, nums of j will be 1, and this will check that whether 1 is divided by 2 to the power 1, and this will results in 1 divided by 2, that means 0. So this 0 is basically not equals to this 1. We cannot go inside our if loop and again incremented j, and that will give as j equals to 2, which is not less than 2. So this inner loop will gets over, and this time we are checking that if our current has a value equals to our maximum or value, and we find that it has a maximum or value as our 3. So we are incrementing our answer from 0 to 1, and again when I is incremented and I will this time 2, this condition inside our j loop will true, that is 2 is divided by 2 to the power this j, that means this, and this time this or is in, is this or is basically odd with this 3 and this 1, and our current will again have a value equals to 3, and this if again gets true, and that will increment our answer from 1 to 2, and finally we have to return our answer as our final answer. Basically this inner loop will checking those subsets where the maximum or value is equals to this 3. Now let us submit this and check if it does passes all the test cases or not. It is passing all the test cases. So thank you so much guys, and if you do understand the concept, please like and subscribe to this YouTube channel.